Right, students. So measurement. Okay. In measurement, particularly length measurement, that is what we are going to see today. Okay, measurement of length. So measurement of length, normally we do with scale. We have a scale. Okay, normal scale will be there. And what is the minimum measurement we can do in scale? Normal scale that we have, you have when you draw. What is the minimum you can measure? Say 1 mm. Okay. Minimum separation or minimum distance that can be measured with scale is 1 mm. Okay, can we measure less than this? No, because minimum separation between two graduation is only 1 mm. That much only we can measure. Okay, so this minimum separation between two graduations or minimum distance that we can measure with any instrument is called least count. Okay, what is least count? This only least count. Least count, see the word least count. That means minimum separation between two graduations or minimum measurement that we can do with that particular instrument is called least count of that instrument. Okay, minimum measurement that can be done with any instrument is called least count of that instrument. So for scale, what is the least count? 1 mm. Okay. Now, what is the need of the instrument that we are going to talk about today? What is the need of those? Because we want to measure less than 1 mm. Okay. Now, if scale is there, this is the scale. Okay, this is 0. And then these are the graduations 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then comes 1 centimeter. Okay, this is 1 mm. But suppose that I am measuring one length and that length is actually this much. Now what shall I do? What is this? It's in between 3 and 4. So I have a problem. Now what I will do is I will do approximation. Approximation means error. Okay, so accuracy will be less. So to increase the accuracy, we require certain instruments whose least count should be less than 1 mm. Then only we can measure this. Right or not? So why we are having these instruments? To increase the accuracy. So first you note this least count, okay? Then you go for the accuracy. Done? Okay. So instruments like Vernier Callipers, and screw gauge or screw gauge is used to increase the accuracy of result. Okay, as their least count is small, as their least count is smaller, where we require more and more accuracy, we'll use accordingly. Now, when you go to the shop, you have to measure the cloth. Do we require that much accuracy? No. If hardly 0.5 mm or 0.6 mm difference is also there, no problem. Not going to affect much. But if you have certain experiments to be done where precision is required, accuracy is required, then we cannot do that. Okay, we have to give the exact value. That's why these instruments are required. Okay, so how is Vernier calipers? Okay, first you note this. Then so we'll talk about Vernier caliper. Have you done this? Noted? Students, this is noted, but yeah. Okay, so we'll go and see Vernier calipers first, then I'll explain you. Okay, so this is Vernier calipers. It's like this. Okay, so these are two outside jaws. Okay, these are outside jaws. What we'll do is whatever we have to measure, we'll insert between these two. Okay, that is later on. First is this is main scale. This is main scale here. Okay, this is main scale, and this small thing, this is we call as a vernier scale that is connected with this jaw, and this is a movable jaw. Okay, so this vernier scale actually is movable. Main scale is fixed. It's just main scale means is what? Same thing we had in scale. The same thing. Okay, there is no difference. Okay, this is simple scale. Where difference between these two is 1 mm. Okay, there is no difference in that. Then what is this? This is vernier scale. This is attached with this jaw. So if suppose that if I have to measure anything, suppose I have to measure the diameter of one sphere. So what I have to do? I have to bring this closer so that this can be fixed over here. So what happens? This is movable. Okay, this is vernier scale. Okay, this is vernier scale and this is movable. It's movable vernier scale. Okay, now what is this here? This is also a scale. So in this scale, what is there? What is the special in this? What we do in this vernier scale, there are certain graduations in this also. Like in main scale, there are graduation in which separation between each point is 1 mm. In this also it is there. So what we do normally, that vernier calipers you see in vernier scale, there are 10 graduations. That means 10 lines you can see. Okay, 10 graduations. And these 10 graduations actually are equal to 9 graduations of main scale. I am giving you standard value. Okay, what we use in lab. In vernier scale, there are 10 graduations, and these 10 graduations are equal to 9 graduations of main scale. Nine graduations of main scale. Okay, so it means, let's go back again, let's check what I am telling you right now. I am telling you that in this one there are 10, let's see, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9 only is in this one drawn. 10 are there and they are equal to how much? 9 graduations of main scale. Okay, fine. Then what now? Now we have to calculate least count because everything is for least count only. Why we shifted from main scale to this vernier calipers? Because we want to have least count. Least count should be less than that. What is least count in this? Least count is defined as 1 main scale division minus 1 vernier scale division. What is MSD? Main scale division. What is VSD? Vernier scale division. 1 main scale division minus 1 vernier scale division. Now, what is 1 vernier scale division? So we say that 10 vernier scale division equal to 9 main scale division. How? From where it came? Came no. That's what we have written. In vernier scale there are 10 graduations. That means 10 divisions that are equal to, these 10 graduations are equal to 9 graduations of main scale. So 1 vernier scale division is what? 1 vernier scale division is equal to 9 by 10 main scale divisions. Okay, let's put it here. So 1 main scale division minus 9 by 10. Again, main scale divisions because 1 vernier scale division equal to 9 by 10. What we are getting? We are getting 1 by 10 main scale division. 10 minus 9, 1. 1 by 10 main scale division. And what is main scale division? 1 mm. 1 by 10 into 1 mm. So what is least count here? 0.1 mm. 0.1 mm is the least count. It's way less than 1 mm, no? 1/10 of 1 mm. That much also we can measure in this one. So accuracy increased. Okay. This is how vernier calipers work. How it will be working, how we are going to measure, how in practicals we do, that's all different. This is theory I am telling you right now. Okay. The theory part is least count is equal to what? 1 main scale division minus 1 vernier scale division. And what we are getting? 0.1 mm. Okay. First you note this. If any doubt is there, ask. Any doubt? Ask. You all have seen vernier calipers? Okay. 12th class? Hashini, you have seen it?
Yes.
Good. Noted this one? Okay. So general formula they gave. What is general formula for least count? They say that main scale division by number of divisions in vernier scale. Okay, general formula. See. Least count. General formula is 1 main scale division by number of division in Vernier scale. In Vernier scale, how many divisions you have done? 10. 1 main scale division means 1 mm. So 1 mm by 10. You can remember that. You can remember it this way. Okay, note. On this only there was one question. That question we will do first. Then we will go back to Vernier calipers and understand that. Done? Okay. The question was like this. Question given was, in a Vernier calipers, n plus 1 divisions on Vernier scale are equal to n divisions on main scale. Find least count of Vernier calipers. Least count of Vernier calipers. Okay, this was the question. Note that. Noted? What to do? Actually, answer we know already. What should be the answer? Generalized answer says least count is 1 main scale division by number of divisions in Vernier scale. So least count should be 1 main scale division. He has not given main scale division is 1 mm or what. So it will be in MSD only. So 1 main scale division by number of divisions in Vernier scale n plus 1. Now this should come because this is generalized form. Our answer should be this. But still let's find it. What we learned is least count is actually 1 main scale division minus 1 Vernier scale division. This is least count. And what question is saying? N plus 1 Vernier scale divisions are equal to n main scale division. Right? So 1 Vernier scale division equal to what? N by n plus 1 main scale divisions. Correct? Let's put it here. This is 1 main scale division minus n by n plus 1 main scale divisions. Okay, so n plus 1 minus n by n plus 1 main scale divisions. What will happen? N and n gets cancelled. What we got? 1 by n plus 1 main scale division. So simple, right? Remember this, but doesn't mean that you will remember this only. note this is very important. Okay, note that. This is the main formula and this is generalized formula. Note it. Completed? Okay, let's go back to Vernier calipers. Okay, we said this is Vernier calipers. Normally when we get Vernier caliper in that condition, what will be there? Obviously this will not be there earlier. So these both the jaws will be together. Both the jaws will be together, one over the other. They will be touching each other. This, okay, will be here only, will be touching it. So in that case, what will happen? 0 of, this is Vernier scale 0 and this is main scale 0. Both will be at the same place. 0 of both should be at the same place. Okay, something like this. Let's see. Yeah. Okay, when not in use, when jaws of both are together. See, 0 of this is Vernier. You can see that there are 10 graduations. Okay. So this is Vernier scale and Vernier scale 0 and main scale 0. It's like this. When not in use. Okay. When you are going to have use, when, like what we had here. Okay, what diagram is here right now. This is in use. So I kept one sphere also here. Right. When it's in use, it will have certain reading. That reading we have to check. Okay. So how will be the reading? Yes, students. Then when we are going to use the Vernier calipers, how will be the reading? You see that the 0 of main scale and the 0 of Vernier scale. Okay, there is a difference because you already have kept what? There is a sphere you have kept between the two jaws, right? So what is the main scale reading now? You see that where is Vernier scale 0? Here is Vernier scale 0. So what is the reading of main scale? This is main scale, right? This is main scale. Okay, so reading is a 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So what is this? 5 mm. These are centimeters. 1 centimeter, 2 centimeter, 3 centimeter. Okay, so this is 1, 2, 3, 4, 5. So main scale reading is 5. Actually 5 plus something. But main scale reading will say is 5 only. It's 5. Now, what is Vernier scale reading? Okay, that's 5 mm. Plus. Now, Vernier scale reading, how to see? Now, you have to see that this Vernier scale, which graduation of Vernier scale exactly coinciding with any reading of main scale. See them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one is matching exactly? I'm feeling this itself. This itself is 1 over the other. Okay. The remaining all is having some difference. So, first one. So, Vernier scale reading is 1. Main scale reading is 5. Okay. This I have written 5 plus 5. Vernier scale reading is 1. Then, what is the final answer? What will be the reading finally? So, reading finally is main scale reading plus Vernier scale reading into least count. Okay, what is Vernier scale reading? 1. Main scale reading 5. So 5 mm plus vernier scale reading is 1. Least count is 0.1 mm. 0.1 mm. So what is the answer? 5.1 mm. What is the answer? 5.1. Check it again one more time. Main scale reading 1, 2, 3, 4, 5. Yes. And then vernier scale reading is 1. Okay. Note this first. This is related to zero error. Okay. We talk about zero error now. What is zero error? Zero error, as the name suggests. When you are not using vernier calipers and both the jaws are together, and sometimes it happens because of the overuse of the vernier calipers. The zero of both scales do not coincide. Okay, normally, whenever we are using, okay, what do you say that? When not in use, zero of both the scales should coincide. It's must. That means it has no error, no zero error. This is having no zero error. But if zero of both the scales is not coinciding when not in use, that means there is zero error. Okay, zero error. That's why it's called zero error. Okay, so there is zero error when vernier calipers is not in use and both the jaws are in touch with each other. But still zero of both scales is not coinciding, then there is zero error. There is zero error. Okay, what happens? Vernier scale 0 will be either on the left of main scale 0 or it will be right on the main scale. Both are possible. So that's why there are two types of zero errors, positive zero error and negative zero error. Okay. Two types of zero errors, positive and negative zero error. Okay, first note this one, then I'll tell you what is positive and what is negative. Come on. Then right. Now let's see what is positive zero error and what is negative zero error. This is here. Okay. So top one is main scale, below one is vernier scale. So you can see that in this one, in this This one here, this Vernier scale. Vernier scale 0 is slightly on the right side of mean scale. Slightly on the right side. What we are calling this as positive 0 error. Negative, you see, Vernier scale 0 is on slightly on the left of mean scale. So we are calling this as negative 0 error. Note this, because we have to measure it. Maybe it's not possible in today's class. Next class, you will see how to measure these 0 errors and how to adjust it in the result. Okay. So this is positive 0 error, that is negative 0 error. Note that one. Done? Okay. So now how to measure this one you will see in the next class. Okay. In next class, this also and screw gauge also and possibly errors also will finish. Okay. Alright then students, see you next time. Bye bye.